Welcome, guys. Faraday's law states that the magnitude of the electromotive force is equal to the rate of change of the magnetic flux, right? So let us say we have a magnetic field like this, and we have a loop or even any object with an area A in this magnetic field. First of all, Faraday's law talks about the electromotive force being proportional to the rate of change of the magnetic flux. So what is magnetic flux? Magnetic flux, represented by this Greek symbol, is equal to the magnetic field density multiplied by the normal area. In other words, magnetic flux is the normal component of the magnetic field density that is passing through the surface. So let us say this magnetic field is going like that. Let's look at it from the side. All right, straight lines like that. And we have an area like that, an object that is bent at an angle here, at an angle theta. All right. The part that the magnetic flux will be the product of this magnetic field and the component of the area that is perpendicular to this magnetic field. So the area here that is perpendicular to this magnetic field will be given by this length of this area will be A. So the part that is perpendicular will be the cosine. So this magnetic field density is given by this B here. So this will be B multiplied by A cosine theta, right? So when you look at this, you have magnetic flux magnetic flux phi is equal to B times A cos theta, right? So what does Faraday's law say again? It says the magnitude of the electromotive force, which we are going to represent with E, is equal to the negative time rate of change of this magnetic flux. So that is minus d change of flux with time. So let's just say this is equation 1 and we'll call this equation 2. All right. Now note from equation 1 that we can have more than one object in this field. Okay, so let's say we have some like that, because in a typical generator or motor we have more than one loop moving in the magnetic field. So basically what this means is that since we are trying to find the flux, we just multiply it by the total number of this area. So from 1, that means if we have more than one loop, or we have n loops with all that area, that means what we'll have is that we'll have the magnetic flux will be equal to n times B times A cosine theta, right? So why don't we put this here? Okay, so insert 3 into 2, right? So what we'll have here is E is equal to minus D N A B cosine theta. All right. So from here, we'll differentiate N, A, and B, N, the number of coils, A, the area, and B, the magnetic field intensity, are all constants in this case, so we take them out. What we'll have is E is equal to minus NAB d cosine theta over dt. All right, so let's differentiate that also. What that will give us is E is equal to NAB sine theta dt d theta over dt. All right, notice that the negative sign has disappeared, okay, because when we differentiated this, it was a minus, okay. So what we had here was minus sine theta d theta over dt. All right, so that's how we got to this point. So now notice that we can have this is equal to, what's this? Change in angle. If we have something like that, rotating like that, is changing angle consistently with time. That is angular velocity. So this is equal to omega, which is our angular velocity. So E is equal to NAB sine theta times omega, right? So E is equal to NAB. Okay. So now you know that sine theta goes from -1 to 1. So what this means is that the maximum value is when sine theta is equal to 1. This is at its maximum value. E max or E naught would be equal to NAB omega, right? So when you look at it, this is the same as saying that the electromotive force E is equal to E naught sine theta, right? But another way of looking at this is because we know that from here, we know that omega is equal to the angle covered divided by the time taken. So theta can be also written as omega times t. All right, we can put this here, and we'll have the final form of our equation is equal to E, the electromotive force, is equal to NAB omega sine omega t, right? And that is Faraday's law in a mathematical form. So we can use this to find the answer for the electromotive force when we're given the number of coils, their area, the magnetic field, and so on. So when you look at Faraday's law that says the electromotive force, the magnitude of the electromotive force is equal to the rate of change of the magnetic flux with time, this is the meaning of that phrase. Okay, so try that on your own and see if you come to the same conclusion, and then you can watch our subsequent videos to see it in action. See you soon.